All right, today we are going to start our first section about trigonometry, actually. I should say about a trigonometric ratio. We're going to start with the tangent ratio. So it sounds a little daunting, but honestly, it's pretty straightforward. And your calculator can do this for you. So to start out, a trigonometric ratio is a ratio with lengths of two sides in a right triangle. You will use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. So these work with right triangles only. The ratio of the lengths of the legs in a right triangle is constant for a given angle measure. This ratio is called the tangent of an angle. So the tangent, if we have a triangle ABC, is a right triangle with acute angle A. The tangent of angle A, which we write as tan A, is defined as the length of the leg opposite to A. So A is right here. This is the opposite leg over the length of the adjacent leg. Okay? So we just write it as a fraction. So whatever the length of BC is, you put over the length of AC, and that is what your tangent of A is. So complementary angles in the right triangle A and B are complementary, so you can use the same diagram to find the tangent of A and the tangent of B. Notice that the leg adjacent to A is the opposite leg to angle B, and the leg opposite to angle A is the leg adjacent to angle B. So before, for the tangent of A, we had BC over AC. If we took the tangent of B, tangent B, opposite of B is AC, and adjacent to B is that leg right there, BC. Notice we do not use the hypotenuse. Okay, that's never going to be your adjacent side. You don't use the hypotenuse for the tangent. So, no hypotenuse for tangent. Alright, so let's see what this looks like in a problem. Example 1, we want to find tangent of S and tangent of R, and we want to write each answer as a fraction and as a decimal, rounded to 4 places. So we're going to do it both ways. Let's start with tangent of S. So tangent S is going to be equal to opposite over adjacent. Okay, that's the way you remember it. You might have heard this before. There's something called SOHCAHTOA. It's this mnemonic we memorize. We are looking at this TOA part, where T is tangent, opposite is our opposite side, over adjacent, which is our adjacent side. We'll talk about sine and cosine next week. So tangent of S, I'm looking at S. Opposite S would be TR. Tangent of S equals TR over adjacent to S. Remember, we don't use the hypotenuse at all. So adjacent to S would be ST. If I fill in those values, we have tangent of S equals TR is 80 over 18. Remember, this is a decimal and a fraction reduced. So if we write this as a reduced fraction, both are divisible by 2, so it would be 40 over 9. Or, if we put it as a decimal, tangent of S equals 4.4 repeating. Okay, so that's our tangent of S. Now let's look at tangent of R. So tangent of R, it's still equal to opposite over adjacent. But now I'm going to look at opposite of R. So I'm going to erase this stuff. We're still not going to use the hypotenuse. It's out. Opposite of R would be ST. And then adjacent to r would be TR. Notice that these just switch. Like if you take tangent of your first acute angle, the second acute angle will just be the reverse of that. So if we fill in those values, it would be 18 over 80. We've already reduced this fraction. It's equal to 9 over 40. And then when you simplify, or when you write that as a decimal, 9 over 40 is 0.225. So tangent of r equals 0.225. So that's how we're going to use the tangent. All right, so how do you find the leg length? All right, so here, this is where we're going to use our actual angles now. So in this previous problem, we just said tangent of S, where S is the angle. But now we actually are given an angle. So we're going to instead write, we're going to look at tangent of this angle right here. But we don't need a letter there. We're going to say tangent of 32 degrees. Okay, tangent of 32 degrees equals opposite over adjacent. And then we're going to fill in what we know. So tangent of 32 degrees equals, our opposite here is 11 over x. Now I want to solve for x. So the way I'm going to solve for x is I have to start by multiplying by x because I need it out of the bottom of that fraction. So I have x tangent of 32 equals 11. Okay, now I want the x by itself, so I'm going to divide both sides by tangent of 32. So then I have x equals 11 divided by tangent of 32. Okay, before we go on, I need to show you something on your calculators. So first of all, in your calculator, to start out here, you need to go to mode. And once you're in mode, you should see this menu. And on the third line, it says radian and degree. You need to make sure that the thing that says radian is highlighted. Okay, so you hit mode. See here, I have radian highlighted, so I need to scroll down, scroll over to degree, and hit enter. Because we want this to be in degrees because we're working with degrees. Then you hit second, quit. Once we're outside of there, we had written that x equals 11 divided by tangent of 32. So how you type that in? You type 11 divided by your tangent. So if you look here, it's in the the fourth row from the top, tangent, in the fourth column. So you type tangent and then 32, because that's your degree, and hit enter. And it gives you this decimal 17.6. So 17.6 is what x equals. So that's how we're going to use it with an actual degree. So let's look at example 3. We want to estimate the height of this lamppost to the nearest inch using the tangent formula. So this is our angle that we're looking at. We want opposite over adjacent. So we would say that the tangent of 70 degrees is equal to our opposite side, which in this case is h. I don't know why it's doing that. Okay. H over 40, which is our adjacent. So to solve for h in this case, it's only a one step. We can just multiply both sides by 40. So we have 40 times tangent of 70 equals h. So notice where the variable is matters on how you solve for it. If the variable is at the bottom of the fraction, it ends up being a little more complicated to solve. But you go back to your calculator. You don't need to do the mode thing again. Once you've set that you're in degrees, you're good to go. So then we type in, we said that it was 40 times our tangent of 70. Hit enter, and we get that the height, it wants to the nearest foot. So it was 109.9 feet, we would say. So let's say 110 feet. So the height is approximately 110 feet. All right, example 4 is about a special right triangle to find tangent. So use a special right triangle to find the tangent of a 60-degree angle. So remember in the last section we had a triangle. We had the 30, 60, 90 triangle, because it does have to be a right triangle. So if one of our angles is 90 degrees and the other one is 60, then the last one has to be 30. So this is our 90-degree angle. This would be our 60, and this is our 30. So we could simplify it. Let's choose that this leg is 1. Then the rule was that the longer leg was the short leg times the square root of 3. So this was the square root of 3. So we want to find the tangent of 60. So tangent of 60 equals 60 degrees. Opposite, which would be the square root of 3, over our adjacent, which is 1. So if we simplified this, it turns out that the tangent of 60 degrees is always the square root of 3. And if we wrote that as a decimal, the square root of 3, if you type that into your calculator, is 1.7. So this is something you could memorize. We actually have a unit circle where you would memorize all of these. You'll do that in college. I don't know if you do it in pre-calc, possibly. But this is our special triangle. It's always true that the tangent of 60 degrees is always the square root of 3. So that's how you're going to use the tangent ratio. Like I said, it's always opposite over adjacent, and you do not use the hypotenuse. So if a problem gives you the hypotenuse, just cross it off. If you're only using tangent, you do not need the hypotenuse. If you have any questions, I have office hours today and tomorrow.